Today in the workshop we'll be working with SD memory cards in the Arduino. We'll see how SD cards work and how to use them in our Arduino sketches. We'll also use an SD card to record and play back the motion of a servo motor. We're making memories today, so welcome to the workshop. Hello and welcome to the workshop. Today we're going to be working with secure digital or SD cards. Now I'm sure you're very familiar with SD cards. You probably use a number of them in your different electronic devices. They are used in phones, they're used in tablets, they're used in cameras. The cameras I'm recording with right now use SD cards. And if you use a Raspberry Pi, an SD card does the functionality of what a hard drive would do. Anytime you need to store large amounts of data inexpensively, an SD card is very good for the application. Now the Arduino by itself does not have a slot for SD cards, but there are several modules that you can get very inexpensively to add SD functionality to the Arduino. You can also get shields that have SD cards either by themselves or with other components like real-time clocks or Ethernet cards. So what we're going to do today is we're going to hook an SD card module, actually a microSD card module, up to an Arduino. They connect very easily through the SPI bus. And then we're going to run a few of the built-in examples that are included with the SD library that is already in your Arduino IDE. And after that, we're going to perform a little experiment where we take a servo motor and a potentiometer, and we will take an SD card and record the movements of the servo motor and then play them back. And you can use that as the basis for a project of your own, either with a servo motor, or you can control DC motors. Maybe you want to make a little robot car that you can program to go around the room and then play that back. You could use this as the basis for that as well. So let's get started and learn a little bit about SD cards. Secure digital or SD cards are non-volatile memory cards. The SD card was originally developed as a joint effort by SanDisk, Panasonic, and Toshiba. SD cards were first introduced in August of 1999. The microSD or TF card was introduced in 2005. SD cards use serial data and communicate using the Serial Peripheral Interface or SPI bus. SDHC cards use the FAT32 file system and have a maximum capacity of 32 gigabytes. SDXC and SDUC cards use the exFAT file system. SDXC cards have a maximum capacity of 2 terabytes, and SDUC cards have a theoretical capacity of 128 terabytes, although currently no cards of this capacity are available commercially. There are modules available for both the SD and microSD cards. All SD cards use 3.3 volt logic, and some of the modules have logic level converters built into them. The modules communicate with the Arduino using the SPI bus. The Arduino IDE has a built-in SD library, so it's not necessary to install any external libraries to use SD cards in your Arduino designs. So here are a couple of SD card modules for you to look at. This is a full-size SD card module, and this is a micro SD card module. And otherwise they're essentially the same. They've got the SPI bus on them. There is, however, one little difference. They both have voltage regulators to drop the supply voltage to 3.3 volts, because that's what an SD card uses, and a micro SD card. This one has another chip on it that does a full logic level conversion, so this this one is made to use with 5-volt logic, and as that, it's a little bit easier to use this with an Arduino Uno. This one does not actually do any logic conversion, so if you want to interface this with a 5-volt device, you're going to need to provide your own logic level conversion or perhaps a resistive array to change your 5-volt logic levels down to 3.3-volt logic levels. This one will accept either a 5-volt or a 3.3-volt supply, whereas this one will only take the 5-volt supply and it uses its onboard regulator to drop it. Neither of the modules really have any components on the back. All of the action is on the front, and there actually isn't very much to either module because really the SD card already has an SPI interface on it. So all it's really doing is providing a connector and some pins, and in this case power supply voltages, for the card to interface it with the SPI bus on the Arduino. So now that we've learned a little bit about SD cards and taken a look at the modules, it's time to get to work with them. Now I'm going to hook my microSD card module up to my Arduino. It's a very simple hookup because it just uses the SPI bus, and after that we're going to start using some of the built-in examples that come with your Arduino IDE. The first one being one that simply writes to the card and reads the data back. So let's take a look at how we're going to hook that up now. Here's how we will connect the microSD card module to an Arduino. Now I'm using an Arduino Uno here. If you decide to use a different model of Arduino, please check the article on the DronebotWorkshop.com website for details regarding the different pinouts you'll need to use. We also, of course, will need the microSD card module itself. We'll begin by connecting the ground from the Arduino to the ground on the microSD card module. We'll connect the 5-volt output of the Arduino to the VCC connection on the module. Pin 12 of the Arduino will be connected to the MISO pin on the module. That's master in, slave out. Pin 11 on the Arduino will be connected to the MOSI pin, the master out, slave in. Pin 13 is the clock pin, the SCK pin on the module. And finally, Pin 4 of the Arduino is connected to the CS or chip select line on the SD card module. Note that if you're using a shield with an SD card module, you may find chip select connected to a different pin, such as 10 or 6. You will have to modify the sketches accordingly if this is the case. We are now ready to experiment with the SD card module. Now all of the example sketches we're going to be using with the SD card module are already included in your Arduino IDE. Go into the File menu and then go to Examples and scroll down until you see SD. You'll notice a number of different examples here. We're going to start with the ReadWrite Example, and as the name might imply, it writes a file to the SD card and then reads the data back. Now the sketch starts by including the SPI library, the built-in library for communicating on the SPI bus, which is how our card is attached, and it also includes the built-in SD library. Then we define a file object, which we're going to call myFile. This is the key to working with files on the Arduino. Now everything in this sketch happens in the setup. We start the setup by opening up the serial monitor at 9600 baud, and then we print to it, initializing SD card. We check to see if the initialization actually happened. So if SD begin does not happen, then we'll print initialization failed. Incidentally, if you have an SD module such as a shield that does not use pin 4 for chip select, you'll need to change the number over here accordingly. If it does initialize, we print initialization done. Then we will go and open a file. So we define myFile as being an SD open, and we're going to open a file called test.txt. Now you can change the name of this if you wish, but otherwise this is the name of the file we will write to the SD card. And this is being opened for a write operation. Then, as long as the file object is okay, we're going to print to the serial monitor that we're writing to it. We're going to actually print to the SD card, and this is how we do it over here. And then we will close the file. You always need to close a file when you're finished with it, and then on the serial monitor we simply print that we're done. If the file didn't open, we're just going to print an error message to the serial monitor. After that, we're going to open the file again, but this time for reading, and notice that you only need to pass the file name as a parameter when you're opening a file for reading operations. Once again, we'll see if we have a valid file. We'll print the name of the file up in the serial monitor, and then this operation here, this while operation, reads everything that's in the file. So as long as we see something in the file, we'll print it out to the screen. So we'll write to the serial the my file read. And then again we close the file. Once again, it's always important to close a file. And remember, you can only open one file at a time on the Arduino. If it didn't print, we'll just print an error message. And that's basically the sketch. There is nothing that happens in the loop. So let's run the sketch and see what happens. Alright, here's our read-write demo. I've just opened up the serial monitor, and basically the whole sketch runs in the setup, so it runs and stops and writes out a line and reads it back. Now you'll notice I've got several lines read back, and that's because I've reset my Arduino several times, and every time I do it, it will write another line. Let me reset it again right now. And there we go. And if you're to count lines, you will notice there's one extra line of testing 1, 2, 3. It appends another line to the file every time that it writes to it. The first time it wrote to it, it opened the file and created the first line. And every subsequent operation, it just appended to that. So every time you reset it, you will get one more line. But it's a very simple demo of how to read and write from an SD card using the SD library in the Arduino. Now the next example we're going to look at is something called a Datalogger. A Datalogger is a device that can, as the name implies, log data over a period of time. It can be used to record things like temperature, humidity. Quite often Dataloggers use real-time clocks to give you a timestamp, but this simple one we're doing today does not. It's one of the examples, again, that comes with the Arduino IDE and the SD library. Now, our Datalogger is just going to use 3 potentiometers connected to the analog inputs of the Arduino. We're going to be able to vary them and vary the voltage going to those inputs, and we'll take the readings from those 3 inputs and write it out to a comma-delimited file that's going to be stored on an SD card. So let me show you how we're going to hook that up, and then we'll run the Datalogger experiment. To run the Datalogger experiment, we will start with the hookup with the SD card that we already have. You will need to add 3 linear pots. I used 10K, but any value from 5K upwards would suffice. Connect one side of the pots to the ground on the Arduino. The other side of the pots are connected to the 5-volt line. The wiper on Control A is connected to Arduino analog pin A0. The wiper on pot B is connected to Arduino analog pin A1. And the wiper on pot C is connected to the analog pin A2. So let's go over the Datalogger sketch, which is also found in the SD card examples in your Arduino IDE. Now once again we start off by including both the SPI library and the SD library so that we can communicate with the SD card module. This variable over here indicates the line that the chip select is connected to, and right now it's connected to pin 4. If you are using a shield where the chip select is connected to another pin, such as 10 or 6, you'll need to change this. Now in the setup, we just open up the serial monitor again, and we print that we're initializing the SD card. And we go and we make certain that the SD card can be initialized, similar to what we did in the first sketch. The action in this sketch is actually in the loop. Now what we're going to do is we're going to create a string and populate it with the values that we get by reading the 3 analog ports. And we're going to call our string data string. And we start off with a blank string. Then we'll read the 3 sensors. It's interesting how they do this. They use a for loop, which is actually a very clever way of doing it. So basically analog pin 0 to an analog pin of less than 3, in other words 0, 1, and 2, and we will increment the loop by 1 all the time. We'll take a sensor value, which is the analog read from the current analog pin 0, 1, or 2, and then we'll write that to the data string, the value of the sensor. Now if the pin is 0 or 1, in other words if it's less than 2, we'll also put a comma after that, and that way we can create a comma delimited string. So this is a very nice way of making a comma delimited string with very few lines of code. After this, we're going to need to write this to our SD card. So we define a file object which we're calling data file, and we do an SD open, and again we're doing it for a write, so we have to specify both the name of the file, which we're going to call datalog.txt, and the fact that we're going to be doing a write to it. Then we check to see if the file is available, in other words, did it open correctly, and if it is available, we will print the data string to it, and then we will close the file, and we'll also print the data string to the serial monitor. If the file isn't open, we'll put an error on the serial monitor to say that we cannot open our datalog.txt file. And this is the loop. We will just continue to repeat it over and over again. Now, one interesting thing to note is that when we first open the file, this file will not exist, and so it will be created. On all subsequent operations, the file will already exist, and it will just append to the file. And that's one of the key things about writing to a file on an SD card. So now that we've seen that, let's put it into action, move the pots around, and watch the different values be recorded on the SD card. Now here's the Datalogger sketch running, and I've got all of the pots right now at one end, and so we're getting values of zeros or the occasional 1, as you can see on the serial monitor. And let me bring one of them up, and as you can see, the value is increasing. As I bring it all the way up, it'll go to the maximum value, which is 1023, and I can do that to the next one, and then to the next one. And so as I move the pots, you can see on the serial monitor the value is reflected, and of course that value is also being written to a file on our SD card, which is over here. And so now that we've written to the SD card, let's take a look at the file that we've actually created. So a very simple method of making sure that you've actually written to the SD card is to simply plug it into a computer. And I've done that with my Workbench computer, and I've opened up the file. Now, the file is called datalog.txt, which is the one that we've recorded. And we've recorded quite a bit of data, as you can see over here. Notice that the file date is not correct. It comes up as December 31st, 1999. But one other thing to notice is that the file name is in uppercase, and whenever you work with the SD library in the Arduino, it reads and writes in uppercase, so it doesn't matter what case you use in your code, everything will be converted to uppercase. But as you can see, I've opened up the file in a text editor, and you can see the contents of the file. Scroll down, and there you go. So that represents the position of the 3 potentiometers. Now, as this is a comma delimited file, I could have also opened it up in a spreadsheet. You could use Excel, or if you're using LibreOffice, you could use Calc, or if you're using Google Drive, you could bring it up into Sheets and open it that way as well. And so there you go. We've written a file to our SD card using an Arduino. Now, the final built-in experiment that we are going to look at today is something called DumpFile. What DumpFile does is it takes the contents of a file and dumps it out to the serial monitor so that you can read it. Now, this is going to work with the file that we used with our Datalogger. So we can take a look at the Datalogger file using the Arduino instead of using our computer to read the file. So now let's go and take a look at the DumpFile sketch. So here's the dump file sketch that we're going to use to read the contents of the file and print it out to the serial monitor. It's actually quite simple. Now once again we'll start off by including both the SPI and SD libraries, and we set our chip select to pin 4. Again, you will need to change that if yours is different. And this is another sketch that runs entirely in the setup and doesn't do anything in the loop. So in the setup, we start our serial monitor at 9600 baud. We print initializing SD card out to the monitor. We see if the card is actually present. So we go and see if the card is there. If it's not, we print out that the card's failed or not present. If it is there, we print out card initialized. And then we'll go and open the file, and we've seen this before as well. We set up a file object, which we're calling data file, and we do an SD open, and this is the name of the file that we're open, datalog.txt. Now, of course, if you want to display the contents of a different file, you'll need to change that. And then we simply go into this if loop. If the data file does indeed exist, while it is available, we will write the contents of it out to the serial monitor, and then we will close the file. If the file isn't available, we'll pop an error message into the serial monitor instead. And that's all there is to it. Again, there is no code in the loop. So let's run that and display the contents of our datalog.txt file. So let's use DumpFile to examine the file we created with the data logger. So let's open our serial monitor. And as we can see, we're starting to read the file. And this is a very long file, as you saw when we looked at it on the computer. So this is going to go on for quite some time. But it seems to work very well. You can see the position of the 3 different potentiometers. And this will continue until we've dumped the entire file, which is going to take a bit of time, so we won't wait for it. We'll move on to the next experiment. So now we've seen a number of examples that came with the Arduino IDE that show you how to use an SD card. It's time to write some of our own code. Now what our code is going to do is it's going to work with a servo motor. We're going to use a potentiometer to move the servo into various positions, and we're going to record those positions on the SD card. Then I will show you a second piece of code where we can play back what we recorded and send the servo through the same sequence. Now you can expand upon this in many different ways. First of all, you could combine the 2 sketches to make a recorder and playback unit if you wanted to. Another thing you could do is you could use multiple servo motors and control perhaps a robotic arm, put it through a bunch of sequences, and then play those sequences back anytime that you want to. You could also use devices that are controlled by pulse width modulation using the same basic code, and things like that would include LEDs or DC motors. As I said at the beginning of the video, you could use this type of code to run a little robotic car around the room in a preset pattern, and then record that pattern so the car could go through it over and over again. So let's take a look at how we're going to hook this up first, and then I'll show you the sketch that we can use to record the movements, and then I'll show you the one we can use to play them back. Now to hook up our servo motion recorder, I'm going to start with essentially the same circuit that we had for the data logger. I've removed 2 of the potentiometers and left the one that is connected to analog pin A0. Next, I'm going to add a servo motor. And I'm also going to add a separate power supply. I'm using my 5-volt bench supply, but you could also use a 6-volt battery. I don't like powering my servos from the same power supply that the Arduino uses. I'll start by connecting pin 9 from the Arduino to the control pin on the servo. Next, the positive side of the power supply will be connected to the VCC pin on the servo motor. I'll connect the negative side of the power supply to the ground on the servo. We'll also make a connection to the Arduino ground. This is very important, so don't forget that. Here's the sketch we're going to use to record the position of our servo motor and write it to an SD card. Now we'll start off by including the required libraries, the SPI library, the SD library, and the Servo library. All of these libraries are built into the Arduino IDE, so you won't need to add anything to your IDE. Next, we define the chip select pin as being pin 4. Of course, if you're using a shield with a different chip select pin, you'll need to change that. We define the pin we've got the pot connected to, which is pin 0, analog pin A0, and we'll also define a value to hold the pot value, and we'll set that to a value of 0 to start with. We create a servo object called myServo and then go into the setup. We'll set up the serial monitor at 9600 baud, print initializing SD card to the serial monitor, and then we will initialize the SD card itself and print card initialized to the monitor once that's done. We'll also attach the servo to the servo object on pin number 9. Now, if you're using a different pin, you will need to change that. Just remember that a servo needs to use a pin that's capable of pulse width modulation. Then we go into the loop. We create a string called data string and initialize it with a blank value. And then we get the value from our pot using the analog read command, and we use the map command to map it from a value of 0 to 1023 down to a value of 0 to 180, which is what our servo requires. And we assign that to the val variable. Then we will append that variable to our data string. Next, we will write to the servo motor with the same value to move the servo into position and delay for 15 milliseconds just to allow the servo to stabilize. Then we'll open the file, and we're going to call our file servopause.txt, and we're going to open it for writing. And then we will write the data to the file. And if the file doesn't work, we'll pop up an error. Otherwise, we close it and we repeat the loop over and over. So we continually write the data to the file as we move the pot position and change the value. So now that you've seen the sketch, let's take a look at it in action. Okay, so we have our demo of our servo recorder. Here's the servo motor over here and the pot that I'm using to control it. Now, as you can see, when I move the pot, the servo moves accordingly. And also, if you take a look at the serial monitor, you'll see that I'm recording the values right now. And those values are being written to this SD card over here. So I'm going to move this around just a little bit. And finish off over here. Let's try to finish around the center. That's a value of about 90 over there. Okay, so now we've recorded the data onto the SD card. Let's take a look at the sketch we'll need to use in order to play that data back. Now here's the sketch we're going to use to play back the servo motion that we recorded onto the SD card. We're going to start off by including the same 3 libraries we did before, and also defining the chip select for the SD card module as we did before. We'll define a string that we call buffer. It's going to hold 1 line of text at a time, and we're going to create a servo object called myServo. Now, all of this sketch is going to run in the setup routine. If you want to continually move the servo in the same pattern that you recorded, you can move some of this into the loop. Now we're going to start again by opening up the serial monitor at 9600 and printing out initializing SD card, and then initializing the SD card itself, exactly as we did in the previous sketches. We'll also attach pin 9 to the servo as we did before, and we will open the servopause.txt file, which is the file we recorded the servo motion on. Now we're going to read that file, and while the file data is available, we're going to read the string until we get to a new line character, which is what this is, and that way we will just read 1 entry at a time. If we don't do that, the entire file will be read and we'll only get the last entry. We're going to print the value to the serial monitor. That's the value that's sitting in the buffer. And then we need to convert that value to an integer. So we're going to use the toInt function. And we'll convert the buffer value to an integer, write that to the servo, and once again delay our servo by 15 milliseconds just to give it time to stabilize. And then we close the data file after we do this. So this is a while loop, so we will do this continually until we are out of data. and if the file doesn't open, will pop up an error message. And that's basically it. There's nothing in the loop, but as I said, you could move this section of the sketch into the loop if you wish to continually move the servo in the same pattern. So now that we've seen the sketch, let's take a look at it. Alright, so let's run our playback demo now. I've got it started, and in a few seconds we should see the servo move. Also take a look at the serial monitor, and there we go. And so this is playing back the movements that I recorded originally of the servo, and now we're parking it at the 90-degree mark. And so this seems to work very well. Alright, well that wraps it up for today's video. I hope you enjoyed it, and I hope it's got you thinking about how you can use SD cards in your own Arduino applications. Now, if you'd like to see more videos like this, the best way to find out about them is to subscribe to the YouTube channel. And you can do that by clicking the subscribe button that's just below this video, or the little robot that's in the bottom corner of the video, and he'll subscribe you as well. Another thing is, if you need some more details about what I've talked about today, or if you'd like to get the code for the SD card recorder and playback that I just used, you can find that on the article in the DronebotWorkshop.com website, and you will also find a link to that below the video. While you're on the website, if you would consider joining my newsletter, I would be very honored. My newsletter is not a spam letter by any means, and it's not a sales letter. It's my way of keeping in touch with you, to let you know what's going on in the workshop, and also to solicit your opinions about the videos and articles that I create, so I can always create better content for you. You'll also find a link to that below the video. So until we meet next time, please take care of yourselves, and I hope to see you again very soon here in the DroneBot Workshop. Goodbye for now.